Okay, welcome again. So after some logistic discussions and let me start sharing my screen. We're going to start with the lecture topic. The lecture topic today, so what we did last time is we ran, I don't know if you stayed till the end or not. That's, we ran an assembly program on the microcontroller, and it's still here, by the way. See my microcontroller. Last time I didn't have power. Okay, see the program is still in the flash memory since last time. I can take out the USB and just connect the power source directly. Okay, and it should have added the numbers. Did we do an add or what? I forgot what we did. Yeah, we added two numbers, right? Two 16-bit numbers, and we turned on the LEDs on the 7th segment, and it is working. Okay. So, this could be a test for your board, by the way, right? Today is March 29th, 2021. We're gonna start. We're gonna go back to cover the HCS12 assembly instructions.
دكتور اسمح لي بسؤال بس قبل نبدأ.
Yes, Mustafa. Yes.
على الكنترولر هذا.
Yes.
هل الباور سورس اجباري ولا بيقدر ياخذ باور هو من الكيبل؟
No. Last time when I ran the demo with you, I ran it from the USB.
يعني بياخذ باور اوفر اليو اس بي.
انت you see my board صح؟
Yes.
You see it?
Yes.
Now now I'm gonna plug in the USB cable, and it worked. But I can program it. But after I do this, I want to go put it on a robot to be mobile, right? I can get the head like this, or if you want power, I also can give it power and remove the USB. It will work. Or you can get battery.
نحطهم اثنين مع بعض ولا غلط؟
لا ما بضر، في protection، ما في مشكلة. يس أنا هيني حطيتهم اثنين مع بعض ما بضر. يس ما بضر. You can program it وهاي power.
بس دكتور كيف بدي أعرف إنه البرنامج أخذه؟ لأنه جربت ما أعطاني إنه البرنامج أخذه.
Okay, let me remind you. Remember last time we forgot to put a current limiting resistor for the LED, so a reset happened for the microcontroller. But then we were thinking, why didn't the LED turn on? But then we discovered that it had a reset and it didn't program. إذا بتذكروا. طيب, let me remind you. أول شيء, when we put the LED and we tried to turn it on port B, a reset happened for the microcontroller. Why did the reset happen?
ما في بروتكشن يمكن اللي هو على الليد.
What does that? Yes. Okay, the LED is not protected. بس شو دخل الريست؟
shorted مثلا أو شيء صار مشكلة.
No, I told you last time that you cannot pull from any parallel port pin. Port B is a parallel port, okay? Every parallel port, I think it's here, isn't it? لما حسبنا قيمة المقاومة, remember when we computed R هذه
طلعت 10.
You cannot, and I told you the maximum current is 10 milliamps. Okay, you cannot pull that more than 10 milliamps on each pin. ماشي? Source. So if you try, you may burn the board. But this board عليه protection, so it does a reset to stop draining current منه. Understood? So we forgot to put this resistor, so it pulled more than 10 milliamp, so it caused a reset.
الريست دكتور كل شيء كل البروجرام بيروح كل الكود عنه.
A reset, what does a reset mean? ما بروح. The program is still here. What does the reset mean, Mustafa? Let me open our project from last time. All right, I'm going to program it again. I'm going to go open the project. We stored it on the C drive. Embedded system design. This is the last one, and this is the one with the LEDs. Yes. So I'm going to open the project, the MCP open. Okay. What does a reset mean, Mustafa?
دكتور.
A reset means that you restart your program. ماشي يعني okay, let me تلاقي لي مكان اخربش فيه. ماشي من هنا. This is the program memory. The first instruction will be stored here at 4,000. Okay, so the program counter has to point here, then continue moving forward, executing instructions. ماشي? So at any point of time, a reset caused by software or hardware or pushing the reset button or draining current from anywhere, a reset will happen. If the program counter was here and a reset happened, it will move and go back to point to 4,000. The first memory location where the first instruction in your program is stored at. طيب.
دكتور كمان الانيشال فاليوز بيرجع عليهم مظبوط صح؟
The initial values if they are initialized. So
اوكي هسه الانيشال بيرجع عليهم بس اذا كان اي شيء معمول وتخزن في ادرس للانيشال بشيلها وبرجع على الانيشال.
ما بشيلها. Let me show you. Let me show you. If it is in the RAM, you did not disconnect power. Okay, يعني. Okay, so first of all, let me do it one by one. RAM start is where the flash memory starts. Equates 4,000. Okay, RAM start is for the data memory. Data memory is the piece of memory where you can store volatile. It's a volatile memory where if you disconnect power, you lose everything. صح? Now, why is the flash memory? Why does the flash memory start at address 4,000? And why does the RAM or the RAM start at address 1,000? Who decides this? The hardware. How do I know it? How do I know about these numbers? I know about these numbers from the MCU register, from the microcontroller, data sheet. So if I go, how do I know these? Go to resources, go to the microcontroller data sheet, this one. Okay, go to the memory map, Control F, memory map. Okay, where is the memory map? This one. See, I mentioned last time that the HCS12 microcontroller can be configured in several modes. The default and normal mode is this normal single chip mode. You see my mouse, right?
Right, Doctor. Yes.
Address 0 to address 400, these are the registers. Port B, port A, DDR-B, DDR, okay, the registers. Then 400 to 1000, this is the E square PROM, the data memory, non-volatile memory, the data non-volatile memory, 4K. Then from 1000 to 3000 F, yani 3F, I mentioned it last time, 12 kilo RAM. In this 16K address space, this is the RAM, the SRAM. Then from 4,000 here, from the 4,000 here, okay, up to 256. But we don't have our biggest window is 16 kilo program memory because we have 16-bit addresses to the 16K.
64 kilo. 64 kilo.
64 kilo.
Yes.
To the 64 kilo, yes. 362 is dependent on the for 8, 16 to the 1664. and this is how much? Wallahi, 1 2 3 4 8 12, and the 7 is 13 14 15.
حتكون 4000.
This is 64K space. بس 64K space, 16K unpaged, 16K paged. Okay, every page is 4,000 to 8,000 is 16K. Is it 4 to 8? Yes, 16K. How do we control to move from a page to page? يعني address 4,000, okay, is address 0 on this page. Address 8,000 and address 0 on this page. Address C000 is address 0 on this page. How do we move from a page to page? There is a register called P page. I'm not going to go to these details, يعني too much. Total should add up to 256. الآن, there is also a mode register where we can choose. The default in our setup right now is that our program memory starts at address 4,000. There is a setting we can make it start at address C000. ماشي. شو جاب الموضوع هذا؟ إنه yes, we have, so our first location in the program memory is address 4,000. It can be C000. طيب, what does a reset mean? It means send back program counter to this location, period. If you disconnected memory, if you disconnected power, all the RAM variables that you initialize here may be lost. يعني, let me show you. الsum هذه, this sum. We computed num1 and num2 and we stored constant. طيب, every time you start your program, you're gonna run these two locations are part of the program. They're gonna go be stored here. But the sum is empty. When is it gonna be filled? With the result of adding the two numbers after the summation happens, after the addition happens. If you disconnect your power, this data will be lost. But if you didn't disconnect it, the data will stay there. I'll show you now live. Okay. A reset doesn't mean that go flash memory or go erase the memory. What's in the program memory here that starts at 4,000 RAM start is going to stay here because flash memory is a type of E² PROM. Okay. Even if you disconnect power, nothing is going to go away. It's going to stay here. But instead of having the program counter method at when the reset happened, pointing to this line of code, it's going to go back to the very first location in program memory. So let me run with you the simulation again. What does a program counter mean? A reset mean? A reset, ya Mustafa? See? Now, yes, I just ran. There is also a reset that happens when you first power up your controller. They call it power on reset. Because when you power on, what do you want to do? What instruction do you want to do? بيكون في circuit that points the program counter to the first instruction in the program. So this is the thing that made the program counter horn, see my mouse, point to address 4,000. Now, if I run, start moving instructions. Now, مثلا here, a reset happened. Okay, let me run more. More instructions. Move, أبصر إيش. I got stuck in the infinite loop. Sum هيو is calculated. هيو. If I reset, المفروض the data هيا is still there. But the only thing that happened, the program counter went back to the first instruction in the program. But the register value is still there because the power is not disconnected. Clear?
Clear, Doctor, yes.
Okay. ماشي. So did I answer your question?
يس دكتور تمام.
Okay. Okay. طيب I'm sorry for the any okay. There's a whole chapter about resets and interrupts. We're going to talk more about these and why 4000. What else? Any for those who studied PIC controller مثلا, the reset causes the program counter to go to address 0 always. Like today we're going to continue the HCS12 assembly instructions, the main ones or the most important ones that would enable us to write programs and point you to where you can find more. Then I want to do this, but next instruction is to start after the assembly instructions directives. We're going to start talking about embedded software design. These are the two main topics I want to start with. The first part is easy. Okay. طيب. So الهدف اليوم, the purpose is to cover the most important instructions that we may need. Again, you don't need to memorize because you will have the data sheet, the instruction set tables with you anytime, right? طيب. First set is the load and store instructions. Load and store instructions move data between registers, CPU registers, to memory, or move data from memory or immediate data you provide, immediate data you provide to CPU registers. As easy as that. طيب. So if you want to put a number that you immediately have or is stored somewhere in memory in a CPU register, what are the CPU registers? Accumulator A, B, D, X, Y. Okay, these are the registers. So you use these two instructions, load and store. Load, in the load, the destination is the register. In the store, the destination is memory. Okay? Load accumulator A, this is addressing mode, is the index addressing mode, صح? Load accumulator A with the contents of memory location where X is pointing at, plus 0. So you get this, you store it in accumulator A, 8-bit. Store accumulator A, address 20, this is address 20, 0020. You get what's in A, store it here, 8-bit. Store X in address 8000, here you're storing 16-bit, so you'll use 2 memory locations. Okay, so let's have 2 quick examples. Okay, fake. Okay, so يعني here load في عندك you have a source destination. Load, your source is memory, your destination is CPU registers. Okay, إذا بنعملهم as a table. This is the load. In store, your source is memory, right? register. Sorry, yes. Your source is CPU register, not other registers, not port B register, مثلا, not IO registers, because those are treated as memory. CPU registers, and your destination is memory. In the load, your source can be immediate number, immediate data that you provide within the instruction. Tamam? So with any addressing mode you want. So what instructions did we see right now? قبل شوي. Load accumulator A, store accumulator A, store X, load D. طيب ماشي. So let's have two quick ones. Load accumulator A. What? 2, X. طيب. Load X immediate 2000. Load accumulator B 1, X plus. Store accumulator A طيب LDY LDY 0, X. Store accumulator A 1, Y. Store D 0, Y. Let's track this program. Let's track this program. ماشي. طيب. This is our data memory. Load X with 2000 immediate. So X will become 2000. X immediately 2000. Okay, this is not immediate. Load accumulator A 2, X. طيب. Then X is pointing where? If this is address 2000, so X is pointing here, right? I1. Now 2. Load accumulator A 2, X. X 2000 plus 2, 2002. 2001, 2002. Here, for example, we have a number $13. So
دكتور سؤال بس.
Yes.
هسه اكس صارت قيمتها 2000 صح؟
قيمتها 2000. Yes, صحيح.
تمام.
Number 2, load accumulator A with the contents of memory location where X plus 2 is pointing at, which is 13. صح? So A is going to become equal to 13. هلا 3. Load accumulator B with 1, X plus. This is a post decrement. So the one here is the decrement increment value. It's not an offset. So B will be equal to the contents of memory location where X is pointing at. X is still pointing at 2000. We did not change its value. But here we're saying after you load, increment X by 1. So X is still pointing here. Let's assume here we have FF. So B will become FF. But as a result of executing this instruction, X is going to increment by 1. Then, يعني 3 كمان, X is going to equal 2001. So this is not valid anymore. It's going to become 2001. So X is pointing here. ماشي. Here, let's assume we have a data 01. طيب. Now 4. Execute load y 0, x. Y equals 0, x. X is pointing here plus 0, so 1. Y is going to become B0001 because it's 16-bit. صح؟
يا
No.
دكتور بس
No. Sorry. So
مقاطعة.
بس أنا هنا خربطت. Let me just fix this one. Load Y with where X is pointing at. Y is 16-bit, but X is pointing here. But I need to fetch 16-bit. So this location and the one after it. So these two locations are going to go to Y. So Y is going to be 0, 1, 1, 3. مصطفى تفضل.
افضل دكتور. هلا بالنسبه اول انستركشن، مش انا بدي اخذ او احط باكس فاليو اللي هو 2000.
Yes.
مش ادرس، هذا فاليو.
because it's an immediate. هي حطينا الهاش here.
بالضبط، بس كانه
Yes.
انت هون عملتها
لا هي 2000 هي. Here.
اوكي، لما عملت انكريمنت
بتصير 2001. وين عملت انكريمنت انا؟ هي. Here. Yes, you increment x by 1. So x is 2000, it becomes 2001. يعني it reflects, if you use it as a pointer, it points to address 2001.
بس هون دكتور انت هي مش ادرس فاليو.
مصطفى x here, what's in x is 2000. Now I used x as a pointer, so the 2000 is an address now.
اوكي خلاص تمام.
Okay. طيب. Then I loaded y with the contents of memory location that x is pointing at. X is pointing at after the increment here, but y takes 16 bits, so we take these two 16 bits, 0, 1, 1, 3. هاي 4. 5. Store accumulator A at the memory location where y is pointing at, comma 1. Y is 0, هاي الفاليو مصطفى 0, 1, 1, 3.
Yes,
but here when I'm using it in the store, it's an address. Let's see it. So you go back to memory location foreground address 0, 1, 1, 3 اللي هي راح تكون register صح لأنه it's below 400. I'm storing accumulator A plus 1 يعني مش at 113 0, 1, 1, 4 هون. طيب انا المفروض عندي فراغ هون. اوكي سامحونا على الضياق بس here 0114 I'm storing what A. What does A have? 13 صح. So here is 1 3. خليني اعملها بلون ثاني عشان تشوفوا $1 3 in this location. Okay, then finally 6. So 5, يعني this is 5. This is 5. 6. 6 store D at the memory location where Y is pointing at. Oh, Y is still pointing at here بس ما عنديش وسع. Let's assume طيب ممكن أعملها هون على جنب. So Y is pointing at address 0, 1, 1, 3 وهذا 0, 1, 1, 4. So Y is pointing at here, right? Y is pointing at here. So we stored A here, which was 1, 3, 1, 3. Then هاي خطوة رقم 5. 6. Store D at Y, comma 0. Y is pointing here, plus 0 is going to say, so it's going to overwrite.
دكتور خطوة 5 على 0114.
Oh, sorry. Yes. Yes. Thank you. So هذه is going to become 1 3. هلا D, what is D? D is A and B, صح? So A is 1 3 and B is FF, right? High 16-bit. I want to store it at where Y is pointing at plus 0. So Y store is pointing here plus 0, so here store 16 bits, so it will overwrite 1 3 here
FF.
and replace this with an FF. ماشي. Just to demonstrate load and store.
دكتور بس 3 كيف طلعت 13؟
هاي
2 عفوا.
هاي load accumulator A. طيب loading accumulator A from the memory location where X is pointing at plus 2. X value is 2000 plus 2 2002. 2002 هيا here فيها 13. أنا assume إنه فيها 13.
اوكي assume.
Yes. Yes. Okay. طيب. Let's go back to our slides. So I assume this load and store thing is clear, huh?
دكتور ممكن سؤال؟
Yes, Mariana.
أنا تايمة.
تيمة تفضلي تيمة.
هلا هيك صار إنه الفرق بين اللود والستور، اللود بس للأدرس والستور للكونتنت الموجود بالأدرس. أنا صراحة ما وضحت الفكرة.
Okay. خلينا أوضحها بسوء أسهل. هاي register A. We know what is a register A, صح؟ register.
Yes.
8-bit register, صح؟ موجودة بالميموري. وهاي memory. data memory اللي هي الأسرام. If we bring issue from memory to the register, this is called load.
Okay.
If we store من register to memory, this is called store. Okay? هلا باللود ممكن ما أجيبها من memory، ممكن أجيبها immediate number.
ها مثل الإكزامبل. مثل الإكزامبل.
زي load accumulator A dollar sign هاي immediate الهاش 01. في هاي الحالة A هذه راح يحط فيها 00000001. Clear?
Okay, Doctor, thank you.
Okay. So this is the meaning of load and store. Load to the register, store into memory. The flags, you no need to memorize these things. The flags, you want to see how an instruction affects the flags. You want to check how an instruction affects the flags. You can just go check it. This is the CPU manual. So Control F, load accumulator A. Let's start here. Load accumulator A. Click on it. These are the flags. This is how they are affected. Zero flag after every load becomes 0. It says here, any load you do, the V flag, the overflow flag is cleared, 0. And negative flag and 0 flag are affected according to what's written here. So negative flag set if most significant bit is 1. What you load? If you load a negative number, the negative flag is negative. If you load a positive number, the positive flag is positive, it will be 0. The 0 flag, if you load a 0, you get the 0 flag will load. Otherwise, it will not. Okay? So no need to memorize these things. You just check it in the instruction set. شو صار؟ Okay. واضح اللود and store? Okay. شو اللي صار؟ Sorry guys. والله شكله راح ناكل مع بعض قطايف برمضان.
ريموتلي دكتور.
ها؟
ريموتلي.
Remotely, yes. طيب, I had a question for you guys. I don't know, ask it now or offline. let me pause it for a second. No, I wanted to ask this. How do I pause? Okay, I'm pausing recording for a second. Let's take a management question. Okay, back. So load and store, clear, huh? Let's move faster. So this is the table from the data sheet. Load accumulator A, load accumulator B, load D, load S. And we just looked at, you can load all the registers with an operand. The operand can be a memory location or a immediate number. Store a register into a memory location. هلا في these three instructions here. Load effective address to S, load effective address to X, load effective address to Y. هذول غير عن load X و Y و A. So load X with an operand, load, شوف لو أحكي لك load X 1 comma Y. Y is pointing here. So what's in here? يعني let's say this is 2000. So 2001. Sorry, 2000, 2001, and 2002. 1 Y 2000 plus 1 2001. I'm going to load to X 16-bit 1 and 2. صح? These two locations will be loaded to X. تمام? The content. يعني if you have 1 2 3 4, X will be 1 2 3 4. But if you say load effective address to X, load effective address to X, well, operand is 1 comma Y. I'm not going to load the content of the memory location. I'm going to compute the effective address. What is the effective address? Y is 2000 plus 1, 2001. So the elective address is 2000Y. So here, X is going to become 2001. Is that clear?
Yes, clear.
Okay. Instead of getting what's inside the memory location, the value in the load effective address, calculate the effective address from the operand and store this in X, not the content. So Y plus 1 is 2001. So X will become 2001 instead of 1 2 3 4. طيب, store, it's a one way. Transfer and exchange instructions. So load and store, we said load and store, you move from memory to يعني load and store, you move between registers and memory. Okay, transfer and exchange instructions, you move data between registers and registers, from register to register. Best. So transfer D and X, D to X, your source is D and your source is X. What's in D is going to become in X. You transfer A to B, what's in A, B is going to become in B. Yani here, if D was 1 2 3 4, after executing the instruction, X is going to become 1 2 3 4. Here, if A was 0 0, after executing the transfer, B is going to become 0 0.
دكتور بتغير اللي في دي او اللي في ايه؟
لا بضل. So you take a copy.
Yes, okay.
You take a copy. Yes. Now, this is if the two operand size are equal. So you take a copy from the source to the destination. But in case the source and destination sizes are not equal, في two scenarios. If the source is smaller than the destination, زي هاي الحالة, transfer A to X. A is 8-bit, X is 16-bit, right? So sign extend A into X. What does that mean? So transfer A to B. If A was 1, 2, after executing this instruction, B will become 1, 2. طيب هلا if okay, if you transfer A to X, this will sign extend A to X. يعني A is تعال اكتبها بالباينري عشان تعرف الساين. A is 0001 0010 صح؟ This is the sign bit. So هذا اللي راح يتكرر. So X will become, after this instruction, X will become, the lower 8 bit will be the same. So 0100 1000, and the other 8 bit, هذول lower 8 bit, هو 16 bit. The other 8 bit will match the sign bit هذا 0000 0000. يعني X after executing this instruction will be what was it?
00
12 صح؟ كانت 0012.
12 yes.
Yes. But
دكتور لو كانت باخذ اللور
لو كانت ايش؟
بالعكس اكس محل ايه.
يعني let me show you. Yes. جاية بس let me show you another example. If A was $, مثلا A1 وجيت عملت له transfer A to X, what will X become? A hexadecimal. يعني A is 1010 0001. When you extend it to 16 bit, it will be 1000 0101 وبعدين الباقيين ال 8 bits الناقصين بصيروا 1 زي هذا الساين. So 8 ones. ف X will become FFA1. You extended the sign. بمعنى ما غيرت sign numbers. So if you take the 2's complement, you get back to the original. Okay? And when you take the 2's complement, all these ones will turn back into 0. Okay, sign extend. Now this is the case. So you sign extend if the source size was less than the destination size. طيب, what if a source size was greater than the destination size? You just crop the lower 8 bit. يعني if you say transfer X to A, X was 1 2 3 4, here A will become 3 4. تمام؟ You take the lower 8 bit. هاي. Clear يا جماعة? And bits are affected according to the what's in the data sheet.
دكتور في طريقة إني آخذ الأبر بايت؟
تاخذه لحاله؟
يعني زي ما إحنا عملنا هسه ترانسفير من X ل A، بدل ما آخذ اللور بايت إني آخذ الأبر بايت إذا كنت محتاج بالأبلكيشن تبعي.
Well, you can shift them right 8 bit و take them صح؟ قبل ما تاخذهم. بدك تعمل process زيادة. أما is there an instruction that takes only the highest 8 bit to an 8 bit register? يعني I don't remember I saw one. بس أنت you can shift it to the right 8 bit 8 times. Then the higher 8 bit will replace the lower 8 bit.
او دكتور في ممكن
صح.
سواب.
Then you transfer them. هلا في shift instructions will get there. مصطفى.
سواب ممكن اعمل سواب على الاكس ريجستر مثلا اللور بايت بصير الهاير وبعدين بعمل ترانسفير.
How do you swap?
زي فليب مثلا.
بجيب لكم سؤال بالامتحان على السواب اذا بدكم.
انه بصير ولا لا يعني بس
يعني ما في انستراكشن سواب. مو انت يعني الانستراكشنز محدودات هيهم يعني الجدول the instructions هي here are your instructions there is no swap instruction. يعني انت to swap maybe you need to shift شيء وحط شيء temporary place وبعدين صح يعني to swap we need to think of a strategy how to swap. اما instruction جاهزه to swap I don't remember there is a swap يعني nibbles.
move دكتور.
الموف يزيد moves data from a register to memory او sorry from a memory to memory. احنا هون بنحكي عن register صح؟ الموف if you want to move to swap if you want to swap the contents of two memory locations 2000 and 3000 تجيب هذا محل هذا وهذا محل هذا we can do this but we need to write a program for this صح؟ You move this to a temporary place then you move this here then what's in the temporary place you get it here. إذا عندي register D مثلا I want to swap lower 8 bit with the higher 8 bit. هاي سهلة كونه D هي A and B right? Store B somewhere and bring it back. Move it to memory مثلا صح؟ Then load A, B يعني store accumulator B at address 1000. Then load accumulator A with address 1000. صح؟ This will get here بس it will overwrite it. إذا بدك تحافظ على A أصلا you can store accumulator A at address 1001 مثلا قبل ما you load it. Then you load accumulator B with what's in 1001. You swap them. Okay? يعني هذه 8 bit مع 8 bit. هلا you want to هلا هاي register X مثلا في 8 bit 8 bit. You want to swap these two locations to these two يعني the lower 8 bit from X with the higher 8 bit from X. There is no way to access the 8 bit alone here. Well, you need to think of a strategy. Maybe move it to a smaller register A مثلا. Store it على جنب. بعدين بس how are you gonna get this?
Maybe دكتور move it
shift
X
it right. ممكن shift صح? Shift right 8 times. هلا في instruction shift registers. You shift it right يعني you move A sorry you يعني you transfer X to A صح? Then shift X right 8 times, right? Then then how am I going to store A here?
لو عملت X to D ضمنت انه صار عندي 2 A and B.
Yeah ممكن تحطها على D وبعدين exchange D وبعدين you get back the missing thing. Fine. يعني you need to plan for your program. It's not one instruction that does this. You need to plan for it. And we're going to come to this software design, how we plan والى آخره. Okay. Where were we? مين سأل السؤال هذا اللي بيضل يضيعنا؟ يزيد.
لا دكتور مش
محمد انا ماليش دخل.
النقص علامه اللي سأل السؤال.
اوكي.
في بروبلم بالكتاب سواب كان.
ما هو سواب ميموري لوكيشنز ولا سواب بايتس بال 16 بت ريجستر؟
لا كونتنت.
السواب بيتس وبدك تستخدم فيها ريجستر وكاري فلاج وقصص يعني you need to think of what you want to do. طيب clear for the transfer instruction. Now احنا we're learning the vocabulary, we're learning the instructions. بعدين we think about the bigger programs. طيب this is transfer. Exchange exchange يعني transfer was a one-way operation. يعني you move what's in here to this register, right? You transfer what's in A to B, what's in D to X, what's in A to X, what's in X to A. One way. Exchange is two-way. Exchange A with B. This will send what's in A to B and what's in B to A. You exchange the value. So this exchange A comma B, the result of this will swap the D, صح؟ يعني it will swap A with B and B with A. يعني lower D is A and B. Exchange D with X. This will swap the contents with D with the contents of X. But the size whole matches. Okay, A and B are the same size, D and X are the same size. Like, what happens if the size doesn't match? If the first operand is smaller size than the second operand, يعني هاي exchange A with X. Well, let's assume A كانت 1 2 X was what? F 0 0. What's gonna happen after executing this instruction?
X بتكون
A
0 0.
easy, صح? A easy. A will take the lower 8 bit of X اللي هم ايش؟ 0 0. But X
ممكن sign extended هون نفس
لا مش sign extended, zeros. Okay. بدك 16 bit, you only have 8 bit اللي هم was A اللي 1 2. So you add zeros 1 2. Here you lost your sign. You lost your sign. إذا بدك to keep it, we'll talk about it. If you want to keep it, maybe you will need to extend A, يعني sign extend A into D وبعدين exchange D مع X. بصير صح؟ طيب. Yes.
يعني لو بدي اعمل زي ما قبل شوي حكوا اخذ الهاير بايت، ممكن اعمل اكسشينج بين دي واكس، بعديها اعمل اكسشينج بين او بي، بعديها ارجع اعمل اكسشينج بين دي واكس.
والله احمد يعني اوكي، يعني you're talking about a register 16-bit register, you want to swap the 2 bytes. هلا I think it's out of our scope هلا نحكي فيها. بدك نفكر فيها وفي انا عادي يعني shift left to shift right rotate يعني what's in the carry flag bring it here, then يعني okay we can do it shift through carry and give it this is a way to do it. هلا you can take it to memory وبعدين or things together يعني you need to plan for it, but there is no instruction. هسا I prefer to
انا فاهم. لا انا قصدي انه بقدر استخدم الاكسشينج بما انه دي عباره عن اي وبي، فلما اعمل اكسشينج بين اي وبي زي كده، او لو حطيت الداتا اللي باكس جوا دي وعملت اكسشينج بين اي وبي ورجعتها.
That's a good idea actually. If you want to exchange the 2 lower byte of X with the higher byte of X, exchange it with D, then exchange B with A, then exchange D with X again. Yeah, that's a good idea. That's a good idea. Did you get Ahmed's point? Smart Ahmed. Yes, good one. Did you get Ahmed's point, guys? Yes. You know what Ahmed said?
Yes, دكتور. واضح.
يعني A and B we can exchange them. That's easy, صح? Because they're part of D. So if you want to exchange the lower byte with the higher byte in Y, exchange Y with D, exchange D, يعني A with B, then go back again. Send D back to Y. Yeah. طيب. Did we cover all the cases here? طيب. If you exchange a bigger size with a lower size, like this one, you add zeros. So here you lose the, يعني B is the smaller one. You take the lower 8 bit of X, you put it in B. طيب, what about X? You take B and put zeros next to it. You lost the sign. You lost the sign. That's why you can do something, there is another instruction called sign extend. هلا الترانسفير ال one way it does the sign extend لحاله automatically, but it's one way. هلا there is a special instruction called SEX, sign extend instruction, that extends the sign of an 8-bit number into a 16-bit number. يعني زي هيك sign extend A to X. It will send A to X, the lower 8-bit, and the higher 8-bit of X will be the same as the sign bit of A. يعني هذه is equivalent to transfer A to X, صح? It will do the same as a result. مظبوط؟
Yes, دكتور مظبوط.
Yeah. Okay. Now the move instructions, we use them. We still have a few minutes, صح? We still have a few minutes. 1 minute. Move instructions. المove you move from memory. Your source is memory, your destination is memory. Oops, what happened? Your source is memory, your destination is memory, or your source can be an immediate. To memory. واستخدمناهم كثير. Any addressing mode. So move contents of memory location 100 to memory location 800. Move contents of memory location that X is pointing at to the where Y is pointing at. You can move a byte or move a word. We used them in our last class demo, صح؟ Clear?
Yes, دكتور. بس هون program memory or data memory نفس الشيء بين الاثنين عادي.
It's an address, Mustafa. Yes. It's an address. Now, the machine code equivalent of this instruction is in the LE01, is in program memory. But you just provide an address. And the difference is that sometimes in some of the modes of the CPU, you can protect program memory. So you cannot go touch it and move things from, if you protect it, then the move will not work. But in principle, these are memory addresses. And what's here in this microcontroller, different than the RISC PIC microcontroller, مثلا, where program memory is a complete different hardware and it has its own address map. Here, all memory types, either program memory, data memory, SRAM, E2 PROM, flash memory, register, are all in the same address map.
تمام دكتور.
طيب, next time we start with arithmetic and logic operations, inshallah. Any questions? Should I stop recording? And if anybody has any issue, you can stay. Thank you and see you next time.